A couple more definite integrals for us here. What are they doing with this over 2 thing here? That's slippery. I didn't notice this until just this second. They haven't this over 2 and I don't see why. So my first reaction is let's get rid of this instantly. Double both sides and you get that your function is 2x squared minus 2, which means this curve should actually be sitting a little lower. But as long as we know that we have the right formula here, we should be all right. So this is a parabola. It's 2x squared minus 2, and we're finding the area under it from 2 out to 3. So we're finding all the area in this region here. If you wrote that as an integral, you'd say it's the integral of 2x squared minus 2, don't forget your dx, from 2 to 3, and now we get to do our antiderivative stuff. So for the 2x squared, power of x increases by 1, divide by the new power, oh good, fractions, and then the antiderivative of 2 is 2x. We don't bother with c for reasons previously discussed, and we have to evaluate that at 3 and at 2 and subtract them. So when we put 3 into this, we get 2/3 of 3 cubed minus 2 times 3 minus, and now we put 2 in and do all that again. 2/3 of 2 cubed minus 2 times 2. All right, 3 cubed is 27. 2/3 of that is 18. Minus 2 times 3 is 6. Minus 2 cubed is 8. 8 times 2/3 is 16/3. Feel a common denominator coming on here. Minus 2 times 2 is 4. All right, so what do we get here? 18 take away 6 is 12. That's our left bracket. Minus 16/3 minus rats. Okay, 4 over 1 is the same as triple both of those, 12 over 3. Instead of 4, I'm going to write 12 over 3 here. 16/3 minus 12/3 is 4/3. And the common denominators keep on coming. 12 is the same as 36 over 3. Subtract 4 over 3 is 32 over 3. Sorry for the fraction-y answer, but it happens all the time when you're doing integrals. So that area underneath should be 32 over 3. And I don't know of any way we could have done this geometrically. The only way you can get this particular area, and lots of others we're going to see soon, is with the fundamental theorem of calculus, doing an antiderivative. So I'm going to preserve the answer here, 32 over 3, and then I'm going to clear out all this work because we're going to need probably about the same amount of space to do this next one. Get rid of that, and that, and that. Okay. Okay, so the new thing is 2 over 3 root x, which I'm going to think of as 2 over 3x to the 1/2 for purposes of the antiderivative that's about to happen. So what they're asking us to do is the integral of 2/3 x to the 1/2 from 1 up to 4. So 1 would be about there, 4 would be about there, and we're finding all this area. Oops, there should be a dx there even though it doesn't really do anything. Okay, so power of x goes up by 1. Now we have x to the 3 over 2. Divide by the new power. So 2/3 times the reciprocal of this is 2/3, so we get 4/9. That should be our antiderivative, and we have to evaluate it at 4 and at 1. So we get 4/9, 4 to the 3 over 2, minus, can I fit this in, 4/9 of, now we plug in 1, so we get 1 to the 3 over 2. Okay. 4 to the 3 over 2 is 8. You can check that on a calculator if you want. Or what this means is 4 times its own square root, which comes out to 8, times 4 ninths is 32 ninths. That's our left bracket. Minus 1 to any power is 1 times 4 ninths is 4 ninths. 32 take away 4 is going to be 28 ninths.